What type of bridges we can do with Open Bridge Designer? We can do pre-station concrete bridges, girders or slabs, steel girders with concrete slabs, roll shapes, built up, tops girder. We can do segmental bridges with two methods of construction, span by span or balance cantilever, as well as casting plate, concrete boxes, and slabs. What about substructure modeling? Well, of course, abutments, stem walls, pile caps, user-defined. Maybe even we can use parametric cells, parametric microstation cells. Type of piers, wall piers, multi-column piers, hammerheads, pile bands, and we can also use parametric cells that could be even user-defined. Variable piers, for example, for substructure can be modeled as well, just defining the cross-section of that pier. We can apply variables to it. We can even stack different types of sections to build piers like that. Or we can even do a hybrid pier. Let's see, combine with regular shapes with some others that may vary linear or parabolically, for example. In some cases, sections are kind of complex. So we need to use parametric cells, parametric microstation cells with variables that allows us to change dimensions of that particular pier that we want to achieve, or even abutment as well. Right? Applying these variables, then we can model almost, if not all, kind of piers or abutments and customize their behavior. So here using variables, this behavior of the abutments, the weak walls, that hinge or corner block could be fully automated depending on the case. That could be because of the super elevation, it could be because of the skew angle of the abutment, and so on. So lots could be done there. As you were saying, the software, right? How we model this. So the process is pretty much straightforward through a single menu, through the ribbon. These are the commands that we need to hit if we want to model a pre-stressed girder bridge. And it's typical. Usually we model the bridge, any bridge, from this case, from the top down. So we need to add the bridge. Then we selecting the alignment. We proceed to step 2, in which define the support lines, meaning the locations of the abutments and piers. And then from the top down, we place a bridge deck. Then we build a beam layout, so how the beams are going to be arranged, the number of beams that we're going to use. On step 5, we apply these beams, the typical section of the beam, through the beam layout. When the superstructure is built, so then we place piers, the corresponding elements, step 7. And then when the super and sub are built, so then we make room for the bearings that are going to be in between them. Later, we can also place barriers, place some accessories to the bridge, approach slabs too. But these are the typical steps to do all of that. Right? So, in a nutshell, this is how we create the bridge following these steps. We add the bridge and we specify the type of bridge that we're going to do. In this case is going to be a pre-stressed girder bridge. The red lines that you see are the alignments and profiles that we have already referenced from our geometry software, in our case, Open Roads. And these blue lines are the support lines. Now, using a template that is predefined, we build the deck. So on this library, we include this deck, and we just specify the beginning and end of that bridge. So that's our bridge deck, reading the alignment and profile. It follows that alignment, and then it automatically creates the 3D model of the deck. Dimensions, slopes are all defined inside the template or could be user defined. We're building here the beam layout and then applying the particular beam that I want to use along that beam layouts. So the beam templates are already part of the software. So we got our ASHTO beams placed there already. Okay, so next step is place the abutments. We are going to place the piers. Again, we're going to cover this into great detail when we uh, get there in future sessions. But this is a nutshell what you can build using templates in this case, right? And these templates are again comes with the software, but it could be also predefined and stored in a library for your particular project. So we build the substructure and we got piers. Right now we're making the bearings here. So the last step is place bearings. We specify the dimensions, specify the geometry of it, the separation between them, the separation between the beam and the actual support, and the software will automatically make room for that bearings. So making room, lowering the cap, right? Lowering the entire pier and make room for that bearing support. So we got our full bridge done. Later, if I want, I can add barriers, right? I can add approach slabs. But in a nutshell, this is how we build the bridge. And it's a full 3D model now. All that information, not only this is a pre-picture of the bridge, but as well as part of being a 3D model and using the templates that we have, we know that every element of the bridge, like the pier or the footing or the column, it's made of concrete because we assign materials. So we know it's made of concrete. We know the physical properties of the concrete. Using the real alignment and profile of the project, we know the exact coordinates of the bridge. We can just read the elevations of the screens if I need to. So right there, this is already an intelligent 3D model.